Hey guys, it's Josie with Queen My Pawn, and today I'll be talking about slope. When you've ever gone to Colorado, and if you haven't been to Colorado, there's a bunch of mountains. You usually see a lot of those mountains, and some are steep, some are not. Like, I've personally walked along Grays Peak Trail, which starts at about, I think it starts at like 9,000 feet. I don't know, it's been a while since I've been there. And at the top, it's 14,000 feet. And usually at the start of the trail, it's very calm. But then like there becomes like these sort of hills that you have to uh, climb through, and then you get to the top. I drew that last part a little bit off. There you go. And so there you go. You're at the peak now. At some points on this trail, it's not very steep. So we would say that if we went all the way to the top of the mountain, and we actually brought skis with us, which is very unlikely, you could actually ski down the mountain, and depending on the slope of the mountain, it would be harder, easy to ski down. Like over here, it would actually be pretty darn impossible to ski down without falling flat on your face. But it would be a lot easier to ski over here because the slope is almost flat and probably you wouldn't pick up that much speed. But over here, the slope, it's kind of steep. So you would pick up, speed, but you would also have enough control. And this could also be the same as a function. If you go ahead and check out the Cartesian plane, then basically you could technically have like a function that goes like this. We don't know what the rule of it would be. Like we wouldn't know what y equals whatever. That wouldn't matter. But we could see that this resembles sort of a mountain. So we could get a line in blue and pick out different slopes at different points. Like over here, the slope's not that high. It's almost actually zero because it's at the top of the hill. And over here, that's another, the point where the slope is zero. I'm kind of bad with my accuracy here. So that's like a bottom of the hill. And over here, you have a different slope, which is like kind of in the middle of the slope of the descent. So you have three different slopes, but you could pick any point on the line and draw its slope too. So like over here, and you would just draw a line in green that went through that point, and kind of like touching the line. Like suppose that this was the line, well, this would be like the slope at that point. It would be increasing somewhat. And one interesting thing to see about all these lines is that they're lines, they're linear functions. So they have the form y equals mx plus b. Now, if you don't know what it means exactly, it just basically means we're multiplying some number by another plus some number. This number doesn't even have to be there. So you could have something like y equals mx. And if we have m equals 3, then you have y equals 3x. That just means you multiply a number by 3, and then you get another number. So let's be more clear about this. And I'll put new Cartesian plane. There we are. Suppose that we have a line that goes something like this. Now this line, you can see that every time we go one to the right in red, we're going one to the right, then we're going 2 steps up. We went from x, and I'll actually write it in a different color. We went from x equals 0 to x equals 1, and y, when x was 0, y was 2. So I'll put y2. And when x is 1, which is right over here, then y equals 4. So x went up by 1, y went up by 2. We would say that the slope is 2 of this line. And that basically means that we would say the line is y equals 2x plus some number, b. Now, why some number? Well, if you plug in these coordinates right here, you get y equals 2, so I'll put 2 equals 2, and for x we plug in 0, so I just put x equals 0 right there, and I put y equals 2 right here. That's all I did. Plus b. Then we keep scrolling down. 2 times 0 is just 0. So you get 0 plus b. Now we got to get b by itself, but obviously any number plus 0 is just the same number. That's the additive identity. So 2 equals b. And so the final thing we have to do is basically just plug 2 into b. And so the linear equation becomes in green. Y equals 2x plus 2. That makes sense. You're multiplying every time that x goes up by 1, the number increases by 2. That's why you have 2x over here. And if x was 0, which it is in this area, x is 0 here, then y was 2. That's where the line started. That's what this point is right here. Now, if that's not clear to you, I have one last try. Suppose that we have that same line, y equals 2x plus 2. Actually, I would like to use a better example. Consider this line. A clear observation shows that the line keeps going onward and onward. I could keep drawing, but it would defeat the purpose. Just imagine that that's one line, right? I'm trying my best. So we can imagine that's one line. And it's basically the same line, just shifted up by 3. You can see that at x equals 0, y is 5, which is this right here. Then when x is 1, y is 7. So clearly y went up by 2. But if that's not clear to you, a simple calculation doing the same process will show that the line is y equals 2x plus 5. You can try that for yourself. But I don't want to hold up the point of this video. And I really have to work with my 5s. Okay. Let's say that I have increased x by 1. So instead of x, I'll just put 2 times x plus 1. After all, and plus 5, of course. So it's basically the same thing, except I just added 1 to x. For example, if x was 6, then the line 2 times 6 plus 5 turns into 2, 6 plus 1 plus 5. So 2 times 6 plus 1 plus 5, which is just 2 times 7 plus 5. So I just added 1 to x, whatever it may be. It's arbitrary. You can pick any number. Just add 1 to it. So that's what I've done here. And I'll put, I don't want to put y because it'll give me a different y than that. So I'll just put y2. Okay, the second y over here. So if we distribute the 2 over the x and the 1, the distributive law, you get 2 times x plus 2 times 1 plus 5. Okay. And remembering the commutative property, you can switch these two around. So in the end, you'll end up getting 2x, or 2 times x, plus 5 plus 2. And when you put this in parentheses, which is association, you could see that in green, these are the exact same thing, except, remember, this is y2, the second y, which is different from the original y. It's this, they use the exact same equation, except the difference will be outlined in orange. We've increased the entire thing by 2, which is what I've been trying to say all along. Every time that you increase x by 1 in orange, y goes up by 2. And I'll just use colors again to emphasize. I've added 1 to x right here. And when I add 1 to x, simple algebra will tell me that I get the same thing again, except now I have added plus 2 to the total. So that's how slope works. It increases the output every time you go up. If you have a line that's going down, like for example, this one in orange, whatever it may be, you can see that the slope is negative, so you'll have a negative slope. And that's really an introduction to it. This will work for any number. That's why instead of 2, we write, as I showed in the beginning, you have y equals mx plus b, where m is the slope and b is just where the line touches the y-axis, which is that. B isn't really important, but m is. M is the slope, which determines how fast the line is rising. Like this, a line that goes like this has a really high slope. Now it's kind of flat, so it's 0 slope. And then it'll be going down, which has negative slope. So every time you go 1 to the right, you have to go many steps up or many steps down just to get back on the line. That's what slope is. And I've given many ways to describe it, so I hope you enjoyed the video. Make sure to subscribe for more, and I'll see you in the next one.